Hey Frank, I think we are getting late for the train. Where is our cab,
Oh
man?
god, Danny, I'm getting nervous, dude.
Hey Frank, look, our cab is coming. Oh no, that was not our cab.
I think we are going to miss the train.
Hey, look at that. I think that's Professor Max.
Hi kids, why are you standing here?
Hi, Professor. We were waiting for the cab to railway station.
Oh, don't worry kids, I'm also on the same route. I will drop you in the station.
That's cool. Let's cancel the cab. We can save some pocket money.
Hurry up kids, get in.
Oh god, the train is running late by an hour.
Oh, come on kids, don't worry. Come, have your seat. Come on Franco, you can also have your seat.
Professor, why that locomotive is pulling the other one?
By the time the train comes, I will teach you how these locomotives and the railway systems work. In a diesel locomotive, the power source is an internal combustion engine. When the loco pilot switch on the system, diesel from the tank is pumped through the engine. At the same time, a starter motor will help to generate initial momentum for the engine crankshaft and the engine starts. Unlike the car engines where the power from the crankshaft of the engine is transferred to a gearbox, here in trains, the power is transferred to a generator to produce electricity. This electricity is transferred to a transformer, then to a rectifier, and then to an inverter to produce a three-phase alternating current which is supplied to the traction motors attached to the wheels. Power to charge the batteries and working of other components like rectifiers, radiators, compressors, etc. are also derived from the same power source with the help of an auxiliary inverter. The red locomotive at the back is an electric locomotive. Unlike the diesel locomotive, electric locomotives does not have any engines. Instead, they are fitted with a series of transformers, rectifiers and inverters, which are comparatively lighter and more energy efficient. The power source of the electric locomotive is the electricity supplied through the electric lines running along the railway tracks. This electricity is trapped and transferred to the train transformers with the help of a device called pantograph. When the pantograph touches the electric lines, the electricity flows to the transformers, then to the ground to the wheels of the train. This will produce an output current in the transformer which is supplied to the primary rectifiers. The rectifiers convert it to direct current and supply it to the main and auxiliary inverters. The main inverter will convert it to a three-phase AC and supply it to the traction motors attached to the wheels of the train. At the same time, the auxiliary inverters will supply power to the auxiliary rectifiers, which will then act as the power source for radiators, compressors, and batteries of the train. The pantographs will be in constant contact with the electrical lines to provide a continuous and steady supply of electricity as the train moves.
controlling the stoppages of trains in the stations?
The movement of trains are controlled by a wide network of signal systems. First, let's see the automatic railway signal systems. When the train passes a signal post with green signal, it will change to red. And when the train passes the second post, the first post will change to yellow and the second post turns to red. When the train passes the third post, first post will change to double yellow, second to yellow and third to red. When the train passes the fourth post, first post changes to green, second to double yellow, third to yellow and fourth will change to red. This process will repeat till the train reaches the home signal point of the next station. Automatic signal system is mostly used when the train is away from the stations. Automatic signal system is controlled by a series of sensors connected to the railway tracks through signal lights and a wide network of relay systems. Let's see the signal system of stations. In stations, the signals are controlled by the station master. The train will wait at the home signal point if it is red. When the home signal turns yellow, it will move towards its designated track in a very slow speed and stop at the next red signal point. If multiple tracks are available, the track indicator attached at the top of the home signal will guide the train to its assigned track. If the train is in the main track, the station master will clear the train with a green light, and at the same time, if the train is in the shoulder track or side tracks, the signal will be yellow in place of green because the train needs to be in a slower speed to change its track to the main line. Now, let's see how the train changes its track. Let's remove the body of the train as well as the chassis of the train to learn it in a better way. The wheels of the train are mounted to a wheel assembly as a set of 4 wheels. The inner edges of the wheel are extended than the outer edges. This will help the train to move through the track as well as to change the tracks. The train will move steadily through the main line or stock line in normal course. A section called tongue rail operated with a gear motor is used to change the tracks of the train. On engaging the tongue rail to the stock line, the wheels are now guided out of the main line to the side line, and that is how trains change their tracks. Now let's see how locomotive changes its direction. In modern times, trains can operate in both directions, but for some reason or the other, if it needs to change direction, it's going to take a very big circle as the train tires cannot rotate independently on its axle like a car tire. To make this job easier, specific type of motorized tables are used to do it in a much more convenient and faster way. Here comes your train. Have a safe and happy journey. Hope you enjoyed our story. Don't forget to like and share our video. If you don't subscribe to our channel, do it right now because we will be coming back with another interesting story in the next episode. Till then, bye bye.